Hello everyone. In this video I am going to write a C program to find out the prime numbers. First we will see what is a prime number. A prime number is a whole number greater than 1 whose factors are 1 and itself only. For example, if you observe 2, for 2 the factors are 1 and 2 only. Suppose after 2 if you go to 3, for 3 also if you consider the factors, 1 is the factor, 2 is not a factor because we are getting the remainder as 1, and 3 itself is another factor. That's why 3 is also a prime number. Now coming to 4, now if you check all the factors from 1 to 4, 1 is a factor, remainder is 0. So 2 is also a factor, 3 is not a factor, 4 is again a factor. That means for 4 we are having 3 factors. Okay, but for prime numbers we must have only 2 factors. Those 2 factors are 1 and the number itself. So other than 1 and that number itself, any other factor is there, we can't consider that number as the prime number. Now we will see the program for this. This is the total program. First I will explain the structure of the program, then I will explain how the loop is functioning and how the conditions are functioning. Okay, the first line if you observe, here I am using 2 forward slashes and I am writing that this program is about prime number. So that means whenever these 2 forward slashes are there in the program, this C compiler consider that as a comment. This particular line will not be executed by the compiler. Okay, so wherever you want to place any comment, then you have to use these 2 forward slashes. Okay, so that is the first point you have to remember. Next, coming to this statement, hash include stdio. These include statements are the header files. So what are the meaning of header files is these are the standard libraries available in the C. For example, stdio.h, this is the library generally consisting of input and output statements. Okay, suppose you want to use the advanced mathematical functions like cos theta, tan theta, logarithmic function, etc., then you have to include one more header file called as math.h. Suppose you want to generate any graphics using C language, for example animating the IC engine, animating the 4-bar mechanism, that sort of animations you want to create using the C program, then you have to include another header file called as graphics.h. Okay, so here I am just using the data collection and doing some mathematical basic operations to find out the prime number. That's why just this stdio.h is enough. Hash included, this is the basic header file required to run any C program. Then main function is the default function in which we have to write the program. So apart from main function, if you want to define any other functions, you can define inside the main function or outside the main function. By default we have to use the main function to write the program. This is the opening of the flower bracket, this is the closing of the flower bracket. In between these 2 brackets only we have to write the entire code. Whatever variables we are using, all those variables we have to define. C language cannot identify the variables by default until unless if you don't specify them, it cannot understand that the variable is belongs to an integer or floating or a character. All these things C program cannot understand by default. You have to specify those variables, whether those variables are integers or floating point numbers or characters, you have to define that. So here in this program I am taking the variables like this. So this is one variable n, so that is the number what I am going to verify, whether the number is a prime number or not, that I am going to verify. No, that number I am storing in variable n. So in for loop I am going to use I. So variable c I am using to count the factors. So that's why initially I am assigning 0 value to it. So whenever a factor is identified, I am increasing the c value. This C value is more than 2 means it is not a prime number. If C value is 2 means this n is a prime number. Something like that I will take the decision by writing this program. Okay. Next, this printf statement. This printf statement is the output statement. So whatever I want to display in the console, so that output I can display using the printf statement. So here what I want to display is in the console I want to display the string as enter a number, so that the user can understand that now you are going to enter a number which will be stored in this variable n. Okay, so for that purpose I am using this output statement called printf. Here I am printing the string as enter a number in the console. Okay, then the next statement is the input statement. So this scanf is the input statement. Syntax is something like this: scanf, open and close brackets. So every statement you have to terminate with the semicolon. This is very important. You can notice the semicolons here. Okay, so scanf syntax is something like this. Here all these are integers. Whatever number I am going to enter, so there is an integer. That's why you have to consider that as percent. A percent is indicating the integer, comma, ampersand n. So the variable name you have to give here. Okay, then automatically whatever value we are entering there, that will be stored in variable n. Suppose I want to check number 3 as prime number or not, then if you enter 3 here, that 3 will be stored in variable n, because this is the input statement. The purpose of the input statement is collecting the data and storing that into the variables. So that is the purpose of input statement. This scanf is doing that this scanf function is doing that work for you. Okay, next. Now I am going to use a for loop to verify that how many factors are there for the given number. Okay, so this for loop part I'll explain in detail in the coming slide, but in the for loop what are the different statements you have to consider, that we'll see now. So this for loop consists of 3 statements separated by semicolons. You can notice here this is the first statement, semicolon, second statement, semicolon, third statement. This first statement is sets the variable before the loop starts. So here before entering into this loop we have to set the value to the variable. Here I am taking the variable as I. That's why here I am defining variable I here as integer. So here initially before entering into the loop I am assigning value 1 to the variable I. Okay, and n value is suppose 3. Then what is the I value? I value is 1, n value is 3. That means 1 is less than 3. Condition is satisfied. Now we will enter into the loop. Okay, so that is the purpose of second statement. Second statement defines the condition for the loop to run. If the condition is true, then only we will enter into the loop. If the condition is false, we will terminate from the loop. We will not enter into the loop. We will end the loop and we will terminate from the loop and we will go to the next statement. Okay, so that is the purpose of second statement. And third statement, what is the purpose of third statement is whatever variable we are taking, we will go on increasing the value of that variable. So here initially we are taking 1, next we have to go for 2, that means 1 plus 1 equal 2, next value we will take. Okay, something in that way. To increase the variable whatever we are taking, we are using the third statement, that you can notice here. Okay, so that is the structure of the for loop. So about this for loop, how we are using the for loop for this prime number problem, that I will discuss in the coming slide. Next we will go to the next block of statements. So these are the conditional statements we are using here. So here I am taking the if condition. C is the count. So here whatever factors I am getting, all the factors I am counting, if the number of factors are equal to 2, then we have to print that it is a prime number. Else, that means number of factors are either less than 2 or greater than 2, then you have to print that it is not a prime number. If this is true, this block of statement will be executed. Then else, use the else statement to specify a block of code to be executed if the condition is false. This if condition is false, then this particular block of statement will be executed. That means this C value is not equal to 2, then that means this condition is false, then you have to go for else. If this condition is true, you have to go for this statement. Something like that, if else will work. Now we will see test cases. So while explaining these test cases, you can clearly understand how the program is working. Okay, now If you run this program, it will ask you to enter a number. This particular text will be displayed in the console. It will ask you to enter a number. Suppose I am entering 3. Then result it is displaying as 3 is a prime number. Something like that I am getting the output. That means this particular statement is executed. And 3 is prime number. Something like that it is telling. Now we will see how the program is working. Okay. Now observe here, n value I am entering as 3. That means here in scanf statement, this n value will be considered as 3. That means wherever n is there, we have to consider 3 in the next line, from the next line onwards. Okay. So from the next line onwards means from the for loop, here you can see the for loop will be something like this now. So initially I equal to 1, then I less than or equal to what is the value of n? 3. Here you have to take 3, then I plus plus. Okay. Now, so initially I equal to 1 means I less than 3 means the condition is true or false. Condition is true. So we will enter into this block. Okay. Now you have to find out the remainder. So remainder of 3 with respect to 1. Okay. So here you check. If n percentage of I is equal to 0, then you have to increment the factors. C is the increment of factors. Initially C value is 0. Okay. If this condition is true, we have to increment that C value with 1. So observe here. Now n is 3. 3% of 1. That means 3 divided by 1. 3 divided by 1 means 1, 3s are 3. That means remainder is 0. Remainder is 0 means 1 is a factor. Okay. 1 is a factor now. Now here remainder is 0 means hence the condition is true. Okay. Remainder is 0 means this is 0, this is 0. Both are equal. Condition is true. Now we will enter into this block. Now C equal to, initially what is the value of C here? What is the value of initial value of C? 0. Okay, that 0 will be substituted here. That means the new value for C is 0 plus 1. That means C equal to 1. After the control moves to the next line, when it is moving out of the if block, then C value will be 1. Then C value will be 1. Okay. So C value is incremented because this condition is true. C value is incremented to 1. Okay. Next, what about I? When the program comes to this particular 18th line, then automatically what will happen is this I value will be increased to 1. That means I equal to I plus 1. Initially it is 1. Now it will become 2. Okay. Now I value will become 2, and again for loop will be executed like this, considering I equal to 2. Okay. For I equal to 2, that means now what is the value of I2? 2 is less than 3. Condition is true. We will enter into the block. Okay. So now n value is 3, I value is 2. 3% 2 means again it is 3% of 2 means remainder is 1. Remainder is 1. So remainder is 1 means 1 is not equal to 0. So this value is 1, which is not equal to 0. If it is equal to 0 only, we have to execute this code. If it is not equal to 0, the condition is false. Condition is false means this particular block of statement is not executing. Whatever value is there for C in the previous iteration, the same value will be there. It will not be increased. So previous value is 1. It will be remained as 1 only. It will not be increased. Okay, because this statement is false. The control is not moving into the block. It is coming out of the block. It is coming out of the block, and here automatically now I value is again increasing. Now it is 2. Now it is I equal to 2 plus 1. That means I equal to 3. It will become I equal to 3. Then when the next time again when the for loop is working, I equal to 3. I equal to 3 means, so 3 less than or equal to 3. That means condition is true. It is moving into the for loop. Then here 3% of 3. 3% of 3 means again remainder is 0. condition is true now. 0 equal to 0 means condition is true. Now it is entering into this if block. Now observe the C value. C value up to here is 1. Now 1 plus 1 means here it is becoming 2. Now C value is 2. Okay. Then control is coming out of this if block. Then when it is reaching to end of the for loop, it will be incremented. Now it is 3. 3 plus 1 means f value is 4. So sorry, I value is 4. 3 plus 1 means I value is 4. So when it is coming to the condition second statement, 4 is less than or equal to 3 means it is false. 4 is greater than 3. It is not less than 3. That means the condition is false means automatically it is coming out of the for loop. It is not executing. So up to I equal to 3 only the for loop is executed. When I is more than 3, the for loop is not executed. It is coming out of the for loop and it is going to the next statement. Now C value is 2. When C value is 2, 2 equal to 2 means it's true. Condition is true. When it is true, you have to print this like this. Printf \n is for new line. %d means some integer you have to print here. Something like that is understanding what the value of that integer means. That integer value is n that we are writing here. %d is a prime number. What is this %d means? N. That means whatever number you are entering initially, that 3 is a prime number, something like that it is displaying. Okay, because C value is 2, that means number of factors are 2. So if number of factors are 2 equal to 2, you have to, this if condition is true, you have to print this. If the number of factors are more than 2 or less than 2, then this will become false. You have to go for else condition and this will be printed. Okay, that is test case 2 that you can notice here. Now I am entering 4. It is displaying the result as 4 is not a prime number. Now we will see how it is finding this 4. Now we will see how the program is executed for this case. Okay. Now, so entering a number, that number will be stored in variable n. Up to here it is clear for you. Now for loop we will see. Now if you consider the for loop, initial statement is I equal to 1. Now n value is 4. I less than or equal to 4, I plus plus. Okay. Now coming to this if statement, if 4% of 1. So n value is 4. Initially I value is 1. Here 4% of 1 we are finding. 4% of 1 is nothing but 0. Remainder is 0. 1 is dividing the 4 completely. Remainder is 0. Condition is true. We are entering into this if block. Then C equal to C plus 1. That means initially C value is 0 plus 1 we are adding. That means C value is now becoming 1. Then when the control comes here, automatically this third statement works and I equal to I plus 1. That means I value will become 2 and again here the for loop executes for the second time like this, considering I equal to 2. So 2 is less than or equal to 4 only, condition is true, it is entering here. Now we are checking this remainder. If 4% to that remainder is 0, if the remainder is 0, condition will be true, we have to count the factor. Okay, so here also for I equal to 2 also condition is true. Then here C value is 1. So C equal to C plus 1 means C equal to, already C value is 1. 1 plus 1 equal to 2. Now in the second iteration C value is becoming 2. Then what about the I value? Here I value is 2. By the time control reaches here, I equal to I plus 1. That means 2 plus 1 it is becoming 3. So by taking I equal to 3, you have to go for third iteration like this. For I equal to 3, so 3 is less than or equal to 4. Condition is true. I plus plus. This is the last statement. Now condition is true. So that's why go to this block. If 4% 3 is equal to 0 or not, we will check. 4% of 3 means what is the remainder? 1. So 1 is not equal to 0. If it is equal to 0, then only you have to execute this code. If it is not equal to 0, you don't have to execute this code, you have to come out of the if block. Okay, that's why we are coming out of the if block, and C value remains 2 only. Here C value is 2, here also C value is 2, it's not increasing. But observe the I value. Here I equal to till now 3. The 3 is becoming 3 plus 1 4 because this last statement is executed here. Now I value is 4. Now by taking I equal to 4, we will go for another iteration like this. By taking I equal to 4, we will go for another iteration. So that means 4 is less than or equal to 4. Condition is true. We will go for another iteration. If 4% of 4, 4% of 4 is 0 again. Remainder is 0. 4 is dividing the number 4 completely. Remainder is 0. So that's why condition is 0 equal to 0 means condition is true. Now we have to do the increment. C equal to C plus 1. What is the C value? Up to here C value is 2. 2 plus 1 means 3. So now C value is becoming 3. Okay. What about I value? I value is 4 here. Now it is becoming 4 plus 1 means 5. So 5 means when you are going for next iteration, I value is 5, which is not less than 4. So that's why it is coming out of the for loop. This condition is not true, that's why it's coming out of the for loop. Up to 4 only it is working. When I is becoming 5, for loop is not working, it is coming out of the for loop. Okay, when it is coming out of the for loop, the value of C is 3. So that's why if you observe here, if C equal to 2, you have to print this. If C not equal to 2, because here C equal to 3, that is not equal to 2, then this else statement will work and this statement will be printed in the console. So that is backslash n means in the next line %d, that is indicating the integer value, is not a prime number. What is that integer value means? N. N means here 4. So that's why 4 is not a prime number, that is displayed in the console. Okay. So something in this way we can write a typical C program for finding the prime number. I think this animated explanation is clear to you. Thanks for watching this video. If you like this video, please subscribe to my channel and share the video and like the video. Thank you very much.